how do you wire all this together in order to make this happen? Now, there's a whole bunch of different ways to do this, and each one of these different types of interconnections are known as topologies. A bus topology starts off where you have a number of computers that are plugged together on one big cable. Now, back in the old days, this cable used to like run up in the ceiling, and everybody would connect up into it. In fact, the cable would literally drop down from the ceiling, and wherever that cable dropped down, that was where you screwed in a computer. And we actually still use that word today. We call it a drop. And it comes back from the old days of what's known as a bus topology. Now, what makes a bus topology particularly nice is that when one computer sends out a packet, this packet will be sent across the bus to all the different computers. Now, this is really important. When one computer sends out a packet, that gets to every other computer on the network. And then what takes place is the actual individual network cards themselves, they see that packet as it comes in, they look at the MAC address, they compare the MAC address to their MAC address. If it's their MAC address, that means it's for them. If it's not their MAC address, they just erase it. Next is what we would call a star topology. Star topologies were actually very rare. In a star topology, what you would have is all of the different computers hooked to this thing in the middle, which for the moment, I'm going to just call it a concentrator. It's funny, a lot of times when you see these star topologies, they kind of just draw a big circle or something for that intersection. Pure star topologies were extremely rare within the networking world. The last type of, and I got to be careful when I say this, common topology was called a mesh topology. In a mesh topology, every computer is physically connected to every other computer. Now you can imagine if you get a number of computers together, this can become pretty messy, and as a result, there was very few mesh topologies used in the real world. Now, I got to be careful when I say very few mesh topologies used in the real world, because what took place is that within the wired world, we didn't see too much of a mesh topology, but within the wireless world, mesh topologies were and still are extremely common. Now, this is important. There are two ways to make a mesh topology. Classically, if we take a look at the graphic, we can see what we have is known as a fully meshed topology. In this particular situation, everybody is connected to everybody else. And there's no exception. Every connection is to everybody else. This is actually quite rare. Now, if you take a look here, we'll see that we have a mesh topology, but not everybody is connected to everybody else. You can still get to everybody, but you might, instead of being directly connected, you might have to go through one or two other computers. So we have fully meshed topology and we have partially meshed topology. The next type of topology that was very common was known as a ring topology. A ring topology literally had a ring of wires that went to every different computer on the network. The secret to a ring topology is that there was a direction to it. It would literally go one direction or another. If one computer wanted to talk to another computer, it would send its packet out on the ring, and that packet would move all the way around the network until it got to the computer with the corresponding MAC address. At that point, that computer could also send data, or it could just pass, as it were, and move an empty packet along, and then if somebody needed to send something, they would just send it along, otherwise they would just pass. That was what we called a ring topology.
التوكن باسنج هو مجموعة من البتات تدور في الحلقة. فمثلا لو كان في جهاز 10 يبي يرسل الجهاز 5 ملف، ياخذ التوكن باسنج بعدين يرسل الملف لين ما يوصل الجهاز 5. لما يوصل الجهاز 5 الملف يرسل تأكيد لجهاز 10. فلما يوصل الجهاز 10 تأكيد الملف، تأكيد وصول الملف، ياخذ الملف تأكيد بعدين يرسل التوكن باسنج مرة ثانية للحلقة.
A switch is similar to a bridge, but a switch has multiple ports and can perform switching tasks much faster. When a message arrives at a switch, the switch examines the destination device address. The switch database contains a list of its ports and the devices attached to each port. It locates the device address in its database and forwards the message only to the port where the device is attached. Most switches can simultaneously switch traffic between multiple ports. This allows multiple devices to transmit at the same time.
Traditional Ethernet that uses a hub rather than a switch is a functional yet inefficient technology. It uses a logical bus topology, which means the hub forwards traffic out all ports to all connected devices, not just the one device to which the frames are addressed. This situation is inefficient because all hosts receive the frames, even if the frames are not meant for them. If a frame is not meant for a specific device, that device discards the frame. Moreover, while frames are on the network is in use and cannot be used by any other devices. This functionality is inefficient because it wastes bandwidth. It also poses a security problem because all devices can read any frame sent to any computer on the hub, even if the frames aren't addressed to them. If two devices try to use the network simultaneously, as seen in this animation, a collision occurs. When a collision occurs, messages become garbled or unreadable, and the network must reset itself before data delivery can again be attempted. The area of the network where a host can receive a garbled message resulting from a collision is called a collision domain.
الفرق بين السويتش والهاب هو أن الهاب إذا كان بيوصل رسالة بين جهاز الثاني لازم يمرر الرسالة على كل الأجهزة ألين ما توصل للجهاز المعني. أما سويتش فإذا كان بيمرر الرسالة من جهاز الثاني فما بس يمرر رسالة للجهاز المعني فقط، ما يمرر رسالة لأي جهاز ثاني غير الجهاز المعني فقط.